Hello, Hackster community. Thank you for the invitation, Jocelyn. My presentation is called Applying AI to Climbing. My name is Mario Bergeron. I work for Tria Technologies as a machine learning specialist, and I'm mostly involved in embedded vision, so applications that have image sensors on embedded platforms, and more recently doing AI at the edge. So taking all these wonderful algorithms and trying to make them run on resource-constrained hardware. And when I'm not working, I'm a woodworker and a rock and ice climber, which is the motivation of this presentation. I've always had this curiosity to see what all these great algorithms could do when applied to my passion, which is rock climbing. And I think this presentation talks more about a journey than an actual finished project. As you'll see, sometimes when things aren't working, you wait a certain amount of time, and state of the art has a tendency to resolve problems that today are not working, may work in a year from now. And my motivation for applying these algorithms to rock climbing are mostly with respect to comparing the climbing techniques between me and my wife. We have different heights. She's 5'2", I'm 5'8". So oftentimes we go about the problems a completely different way. And I've always wanted to try to analyze that. So this is why I tried to apply these AI machine learning algorithms to rock climbing. So I think the event that sparked this is when rock climbing became an official sport of the Olympics. This was for the 2020 Olympics, which actually did not occur in 2020 because of the COVID pandemic. They occurred in 2021. And at that point, my expectation was, after seeing all the wonderful things that they were doing for other sports like soccer, overlaying lines on the fields and doing some 3D reconstructed playbacks, I was expecting to see something similar with the rock climbing field. So, for example, comparing two climbers. So I think in my case, I would start from just video files, so recorded footage, and then I would start by detecting the humans in the scene, so trying to detect the climbers. And if there was more than one person in the scene, at this point it becomes interesting or important to track each of these people so that we could, from one frame to the next, know which is the same person, so we could do further algorithms on this. And if there's many people in the scene, or sometimes even more than one climbers, we may want to zone in on one specific climber. So this would somehow try to isolate one of the climbers. And if we're doing comparison, we're doing this on many video feeds. And then finally, to do the actual comparison, we need to align the videos of where the people are on the route and then do the final comparison. So this is the paper napkin design, if you want, of the application. So I started by creating a simple use case where I did a manual side-by-side montage of two videos of my wife and myself climbing just as a first test scenario. But this is the simplest use case you can have because as you can see, each video has only one human in the scene. So there's no need to track and isolate the climber. There is only one person. But in more complex scenarios, we may have separate videos so they won't be manually aligned like I've done. They may have many people in the scene, so this is where the tracking and the isolating the climber of interest becomes important. So this is still, it's better to start simple and then work our way up in complexity. So this was my starting point. So in 2021, I tried the pose detection models on some of this climbing footage and was rather disappointed. I tried two of them, a two-stage model, SSD plus FPN, as well as a single-stage model, PoseNet. Could have tried YOLO as well. I don't think I did try YOLO at that time. But as you can see, the algorithms, both of them had a very hard time detecting a human, period. And when it did find one, it had a hard time actually identifying the pose, so where the arms and the legs were in the scene. So this was not very successful. And so this is the second one. This is PoseNet. But what was actually peculiar is as soon as the human being in the scene was touching the ground, the algorithms would work fine. So the problem wasn't the algorithm per se, it was the training data that was used to create these algorithms. So obviously, they didn't have human beings hanging from walls or from the roofs in their data set, which is why in this article, the second publication, I called the odd human data set. So the use case of rock climbing just put human beings in unusual poses that were not part of any of the training data sets. So the algorithms were not working. So at this point, two options presented themselves. Either I created my own training data and retrain these models, or just wait for maybe the state of the art to evolve, and which is kind of what happened. But in 2021, I was at the point where I was not even able to detect the rock climbers. So that was not very encouraging. So I put the project on the shelf and waited a year. And then in 2022, I saw an article from Learn OpenCV showing how YOLO v7 was used to detect human beings in unusual poses. So this is a nice use case where the algorithm is having a time, media pipe pose detection is having a hard time differentiating the human from the horse, whereas YOLO v7 was doing a better job. So obviously you can see here not only the algorithm had evolved, but also the training data was taking more of these odd human positioning. So I said, I've got to try this on my use case. And lo and behold, it worked very well. Not only did it detect all the humans in the scene, but it also correctly detected the poses, so the arm and the leg positioning. So that was a good sign. So I tried it on a slightly more complex use case here, where we have two people in the scene. So in this case, you can see that I put the overlays in the middle portion just so that we could start seeing the comparison of the two climbers on the same reference point in the middle. So this started working pretty well. So here we were in 2022, finally able to detect rock climbers in the scene successfully. The next topic now is tracking. And the reason we want to do tracking is, if you look at this scene where I've got a lot of people in the scene walking in and out of the frames, you can see that the object detection networks are returning a bunch of identified objects, in this case are human beings, but with different IDs, and the IDs are not consistent from frame to frame. As you can see in the middle here, this is me climbing. Sometimes the ID will be 0, sometimes it'll be 1, sometimes 2, sometimes 3. So there's no knowledge of where is this same person from one frame to the next. So this is where we need to start looking at tracking. And these tracking algorithms are based on position in the scene, but also on similarity. So in this case, what makes this difficult is if I'm climbing and I fall, I'll actually change position quite a lot. Earth gravity pulls you pretty fast to the ground. So I did try many tracking algorithms without success. And then in 2023, there was a fairly popular tracking algorithm called Deep Sort. This was the most promising candidate. But in this use case, once again, for rock climbing, as you can see on the right video, it's continually losing me as soon as I start moving or falling. So this is either because it's not able to distinguish me from the features of the rock, or it's confusing me with other people in the scene. But the main takeaway here is that Deep Sort was not working well for this specific use case. So here I was, 2023, able to detect humans in the scene, but not able to track them. And this is also, well, brings us to 2024, where we had the next Olympics, where I was expecting to see a lot of 3D visualizations of the climbers on the walls, but this did not happen. Although there were 3D visualizations of the static wall in the holes, which was pretty interesting, there was no actual replay of the climbers or any kind of comparison between climbers, which was kind of disappointing. But my prediction for the next ones in 2028 will be we'll start seeing this kind of side-by-side comparison and 3D visualizations of the climbers doing their routes. So will the Olympics achieve this goal before I do? I don't know. We'll see. And then at the end of 2024, not too long ago, I saw this new algorithm, which was called Samurai. It's actually a tracking algorithm. Um, its downside is it currently only supports tracking one object in the scene, but that is exactly my use case. I want to isolate one climber, so that's perfect for this use case. And it's doing really well despite occlusions, losing the object for a few frames. Like you can hear with the smoke, it knows after where it is again. You can see this person. So I said, okay, I definitely have to try this on my use case. And lo and behold, if you look at the comparison between, on the left, we have just the pose detection alone. In the middle, it's the deep sort, which is having a hard time following the climber. And on the right, it's the Samurai algorithm. And it's working perfectly, actually. So that is very cool. So here we are, in end of 2024, we're able to detect climbers, not only track them, but isolate the climber of interest. Things are going really well. So what would be the next step? I think instead of coding the alignment and the comparison, I think the next step would be starting to look at LLMs, and more specifically agentic AI. Here I'm showing an example that I just experimented with a bit from Landing AI, which is an online cloud service provided by Andrew Ng, a renowned specialist on machine learning. And if you see, we provide some video footage and a prompt. And so in this case, identify the climber, the rock climber of interest, track this climber, count how many times the climber falls, and determine if they reach the top. And then these agents come back with describing how they're going to tackle the problem. So I've generated code. I'm going to just find which climber makes it to the highest point and see if there's sudden downward movements. That'll be identified as a fall, etc., etc., etc. And then it provides the code that you could run. And you can see here on the bottom, it actually shows like intermediate results of tracking. And it turned out this algorithm, it did not use the Samurai algorithm I had identified, but it used the underlying SAM2, which is the segment anything model. And it wasn't quite working to my liking. So it was actually not counting any falls. So there's a few bugs to work out. But I think these are definitely tools that will be that I will experiment with to see if I make it further in this project. So if you found this interesting, if you want to dive deeper into the subject, you could follow. I have a project on Hackster describing this, or just follow me on my Hackster profile. That's it. Thank you very much.